going to look at how you can compare different graphs. This is a PowerPoint that I am just going to walk and talk you through. So you will likely need to pause the video so that you can do the sketching that you need to do for the graphs. I don't think it's necessary for you to write down every single word on this PowerPoint. I'll kind of highlight what you need to know. So again, we're going to look at how you can compare different graphs. You do not need to write all of this down. What we're going to be looking for when we compare graphs, we're going to look at roughly the center, the measures of center. We're going to look at how the data is spread out, how much the data varies. We're going to look at the shape of the graph, if there's any like symmetry or peaks in the data, high points in the data. And then we're going to look for anything that would be considered unusual, which would be our outliers. So first thing is spread. So this refers to how much the data varies. So that should hopefully make you think of range. So here are two graphs. The top one is not as spread out as the bottom one. So the range on the top, the data, whatever this data is about, which I don't know, but it goes from 3 to 7. The graph that's on the bottom, the data ranges from 1 to 9. So you could easily say that the graph on the bottom has more spread than the graph at the top. All right, looking at the shape. So on the shape, whoops, sorry about that. On the shape, there might be some new vocabulary. So again, you might want to pause this so you can get the words down. First graph looking at, this is symmetric. It doesn't have to be completely identical on the right and the left, but there is definitely a fold line that we would say the right side is very similar to the left side of the graph. So we would call this one symmetric. We would also call it unimodal. Now that doesn't completely translate to mean one mode, but it does imply that there is a peak in the data. So there is, if you think of this as a mountain, there's one mountain peak up there on bar 5. So the term is unimodal, but again, we don't want that to mean just one mode, and I'll show you why when we get to some other graphs. This one is also called bell-shaped, and it's kind of hard to see without being able to draw it, but there is definitely a curve that would look like a bell. This never has made sense to me, but a graph like the one on the left, well actually both of them, but more obviously the one on the left, skewed left. That means the short bars are on the left. So more of the data is to the right. So it's never made sense to me. It always seems like it's backwards, but skewed left is when the higher bars are on the right. So the majority of the responses are bars on the right. So looking at the graph on the right side, we can see that this is in age, and it's talking about cardiac patients, female cardiac patients. So it would make sense that this would be skewed left because cardiac patients we usually think of as being older. So the graph on the right shows that the patients that are older in age are the ones that are cardiac patients. You can probably guess that skewed right is going to be the opposite. So the graph on the left, it's very, just kind of looks like a set of stairs, but the graph on the right is showing the number of female patients and the charges. And this one is a little harder to maybe comprehend, but the data is definitely skewed to the right, which means that the bars are higher on the left. So short on the right. Uniform isn't very common, but it would be when all of the bars are the same. So theoretically, if you were to roll a die, the chance of getting any of the numbers would be even. like uniform across the board. Experimentally, we know from rolling for our partners that we definitely get one number more than the others, and it's not a uniform. Okay, so here's bimodal. So a few slides back, we looked at unimodal, which I had mentioned at the time, we don't want to think of that as being one mode. It's more of one peak. But this graph is bimodal because we have two peaks in the data. One is at 3 and one is at 7. I'd also consider this graph to be symmetric because if we folded this graph right through the center, right around the 5th bar here, the right and the left would mirror each other. Here's a graph that we would also consider to be bimodal, but it's not symmetric. So there is a peak in the data at 3, and then there is another peak at 7. So we call this bimodal because there's two peaks, but it's definitely not symmetric. All right, we're going to talk about unusual features in a graph. So the most common one that you guys know is outliers, but there are also gaps in the data. So these graphs are examples of gaps. So on the left, there was no frequency for the numbers 4 and 5. And again, these graphs were just made up for this purpose. So whatever the question was on this graph, there was no response given as 4 or 5. We don't skip them, we leave them so that we can show that there was a gap in the data. Same thing on the right. The graph on the right, there's a gap between, I don't know, maybe 138 to 152. So we don't skip that information, we leave a gap. So a gap is an area where the frequency is 0. We talked about outliers already. So the graph on the left, you can see 9 is an outlier for sure. And for one thing, the outlier is going to have probably a frequency of 1, and you would have to have a gap. So there is no way that you could have an outlier without having a gap. But just because you have a gap doesn't mean there's an outlier. So in order to have an outlier, you would have to have a gap. So both of these are going to show a gap in the data with an outlier. So right here we have on the graph on the right, there is the bar at 27 does have a frequency of 1. If we look all the way to the right, the bar that has the 97 looks like it also has a frequency of 1, but there's no gap there. So we know that 97 would not be an outlier, but 27 likely would be. And again, there is the formula that we talked about last week that would where you would work out mathematically to make sure that 27 was in fact an outlier. All right, so these are just some things to think about. What shape would the following situations have? So if there was a really hard test in school, I think most students would describe the graph of a really difficult test as skewed right. And what you're implying here is that the test was difficult, so very few people did well and most people did poorly. All right, a really easy test would, for the same reason, be the opposite, which would be skewed left. And this would imply that the test, an easy test, means most people did really well. Rolling a 6-sided die 1,000 times. Well, this one is a little bit difficult because, like we said, theoretically, rolling a die would be even. Experimentally, it wouldn't be. The fact that we're rolling a die 1,000 times, it wouldn't be a uniform amount, but theoretically, the graph would be. Heights of male students at Mabry. So if we're talking about Mabry and we're looking at just the guys, I would probably say that this graph would be bimodal. It could even be trimodal, but I would say bimodal because in all likelihood, the 6th grade students might have an average height, and then there might be a height of 7th grade and then a height of 8th grade. And there could be differences between those. The last example is asking about combined heights of male and female students. That one would probably be bimodal or trimodal as well, because what would end up happening is some of the girls would overlap the heights of the boys. But if you have looked around in the halls, or even thinking about yourself back when you were in 6th grade, your height has likely changed. So the 6th graders, when you look at them, some of them are very tiny. And then you look at some of the 8th graders and they look as if they're full-grown adults. So it's definitely at least bimodal, possibly trimodal, and probably not symmetric. So that's just a quick overview of the ways that we describe graphs. So what you're going to be doing is looking at different graphs and describing the characteristics of them. And again, just to go back to this screen right here, we typically, when we describe graphs, we look at about the spread of the data, the shape, and anything unusual. So typically we like to mention a vocabulary term from each of those areas.